Thanks for coming. I'd like to give a short talk about charm, and at the end there's time. Can you all hear me okay? Yeah. On and off. Sorry, not much I can do about that. It's going to be a similar talk to last year, but what I'd like to do is cover the changes that have taken place in the language since last year.
Going out again. Is that fading in and out again? It's annoying.
Yeah,
Sorry.
I'll take it off.
Take it off.
Let's give you another mic.
I've nearly got it in my mouth now, so hopefully that'll work.
Yeah, should do.
It's a connection rather than the
Okay. Oh, okay. Probably good. I don't know what it is. It's like okay.
I'll fade you up in a second when I get back in. Right, there you are.
Is this switched on?
Should be.
Hello, hello?
Hello, it's working earlier.
Oh, okay. Okay, so here we go. Sorry, a bit of feedback there.
Bruce, the mic's working.
Right, so I'd just like to run you through a few slides to start with. Right, first slide, what is Charm? Charm's a high-level programming language and a tool set, which I developed. It's been around quite a long time, and I've done a fair bit of work on it over the last year. It runs on all RISC OS platforms, including the Raspberry Pi. So my latest challenge was supported across to that, but thanks to the good work the RISC OS guys have been doing, it's pretty straightforward. Why would you want to use Charm? Because it's easy to learn, it's simple to use, quick to install, you just download it and unzip it. It's a powerful language, so the whole of the Charm environment is written in Charm. It's fast, quite a bit faster than, say, BASIC. I don't know if anybody saw Gavin Rape's article about it, but compared to RISC OS, it's an order of magnitude faster. And best of all, it's free. If you have any questions as we go through, please shout me, it's fine. Well, I designed the language. Yeah, my language, yeah. So everything about it is me, really. So if you want to find out more about Charm, go to the Charm website, and there's a lot of information, including the syntax of the language, downloads for all the tools, screenshots of demos. If you're interested, you can join a users group, and you can post questions on there, and I'll get back to you and try and answer them for you. Please visit my stand, and I've got some business cards that you can pick up on, and it's got the web address on it. Also, you may have seen, I've got some pictures of Mandelbrot set images that were developed using the Pi program, which I wrote especially for this show, and I'll be happy to demonstrate that to you later. I don't know how many of you are programmers, but just quickly run through what you get with the Charm toolset. When you run the Charm tools, first thing you see is an entry on the icon bar at the bottom, and that's called the Charm shell. And using that, you can compile and edit Charm code. You get a fairly powerful editor, which is automatically invoked if there are any problems in your program, once you at the correct position that the error happened, with also giving you an error message to see what went wrong. You get the Charm compiler, which is obviously the key part of the tools, and that converts the Charm source code via a step of generating ARM assembly code into binary format. So in this diagram, conceptually you see the source folder, which contains the Charm source code, going through the compiler, and being fed into the ARM assembler, and then going through to the object directory, which is where the binaries are stored. Actually, the ARM assembler is built into the ARM compiler, so you don't have to run it as a separate step. You can do the whole thing in one step. And once you've compiled all of the source code files you need for your application, you can run the charm linker to generate either a RISC OS application or RISC OS module, which is then ready to run and doesn't need any other support. You can just put it on any platform and it should run fine. You get a little search tool for searching through source code, which is written in Charm. And of course you get runtime libraries, which have been developed quite a bit over the last year. And they allow you to do things like input-output, math stuff, setting RISC OS variables. So there's a whole raft of libraries which are documented on the website. If you don't have what you need, it's very easy to write your own library. And the reason it's so easy is that you can inline ARM assembler code into Charm, and in the ARM assembler code you can make software interrupts to RISC OS using the program reference. So you can just say, well, I need to use this function. It's not there at the moment. Slide whatever it is. Call it from Charm, and away you go. If you go to the Charm website, you'll see there are a number of demos that come with Charm, and they're kind of like an introduction to the language. And the idea is that younger generation might be interested in some of them, having a play with them, might lead them into doing a bit of programming. So one that they probably like is called Decapedes, and it's like a retro game where centipedes go around the screen and shoot each other. Some of that is written in assembly language for speed. At that time I might have done that at the end. There's a Chinese checkers program, that's a picture of it on the slide, which is quite tricky to beat. It uses algorithms that are used in chess programs to figure out what the optimum move is. I don't know how many you play checkers. But I reckon I'm quite good, but I can't beat the program anymore. So it's getting there. There's Mandelbrot set generator, which is a toolbox-based application. So it runs in a window, and you can use it to explore the Mandelbrot set. So when you first run it, it comes up with a picture of the whole set, and you can zoom into various parts that you're interested in, and you can kind of dig on down and see what you can find. So I'm happy to demonstrate that later. There's a toolbox demo program. I think the toolbox is quite useful for generating RISC OS applications, but it's a little tricky to use. So the demo program shows you how to bring up windows and dialog boxes and various other components that it contains. You can crypt that code and put it into your own application. There's a live demo, which is John Conway's live, which just is a finite automaton based certain rules. It just looks quite pretty. There's a graphs program that draws a variety of mathematical graphs to illustrate the maths library. And then there's a couple of really simple demos at the end, the source code of which fit on a single page, so that if you want a really simple introduction to the language, you can have a look at those. On this page, I've taken a few measurements of how fast Charm is and how much code it contains. So, as far as speed goes, on PC, typical PC, it can compile between 2,000 and 3,000 lines a second. So that's fast enough that you can do just-in-time type development, or you can do agile development where you don't have to wait around for builds. You just want to try out something, some small change, and you won't be put off by the speed of the tools because it's so fast that it's done in a couple of seconds, even for quite a large program.
Is that under RPCMU then?
That is under RPCMU, yes. Charm itself contains about 50,000 lines of code, of which 5,000 lines are demos, compilers about 18,000, And the libraries are about 15,000, the biggest of that being the Toolbox library, which is pretty massive. So to build the whole of Charm takes between 15 and 30 seconds, and it's a lot faster on something like an ARM Mini, which has got a fast processor. So you can see that you're not going to be limited by having to wait around for things to happen. Okay. So as I said, the language has moved on quite a bit in the last year, and I'll just cover the key things that have changed. A year ago, you had to put end underscore on the end of all Charm constructs, which was a bit of a mouthful. So instead of having to do that now, it uses squiggly braces to delimit constructs, which is more in line with modern programming languages. One thing that I found really useful was before you had to put how many items were in an array inside the square brackets, but now you can leave that out and just use an initializer and it will work out for you how big your array is. Quite handy for Charm beginners, there's a new project utility which was written by Gavin Wraith. I modified it a bit since then, but essentially you can run that and it will create a Charm project that will build for you and just output some simple stuff to the screen, and you can use it as a template for writing your projects. Since a year ago, the Charm shell I mentioned earlier has got a login window, and it will report errors in windows for you, nice boxes, and give you an option to go and edit where your problem is. There's a couple of new keywords in the language called import and export. A year ago, you had to include files that helped you link modules together, very much like in C++ and C, if people know those languages. I've gone down the Java type route where that's all been done away with, and essentially the compiler will generate the linkage files for you. I'm going to talk a bit towards the end about the implications of that, but it does away with having to manage a whole load of files, basically. Big change I made recently to get things working well on Raspberry Pi was to add VFP support. If you don't know what that is, it's vector floating point. The old version of Charm just used the floating point emulator that was available on RISC OS. Now I can generate the coprocessor instruction set for the Raspberry Pi chip, and that makes floating point an order of magnitude faster. And that's one of the reasons that I can do Mandelbrots in under a minute now rather than taking an hour. The other big change that's been made is to add object-oriented programming to Charm. What this means is that you can instantiate objects, and they have their own copy of their data. And there are new keywords to support this. So this refers to the current module. You can use new to create a new object and delete to delete it, or you can create it directly on the stack, or you can create it as static data. And last but not least, there's a couple of new procedure names that you can use to run code as the application is starting up and as it's closing down, which is quite useful, I found. This slide shows you what Charm used to look like a year ago and what it looks like now. And the stuff in red is basically what's changed. So as I mentioned, you can see that all the end underscore stuff's gone. We've got squiggly braces instead. At the top, you see the include file that used to be there that you had to put in has gone. And instead we've got an import, and that's importing the standard library module called out, which is used to output characters. By the way, this is the source code for the Civ demo, which is included on the distribution, and just outputs prime numbers from 1 to 1,000. The libraries have been reorganized a bit, so the library names changed from rtl.out to out.vdu. And another change, which has been quite handy, is you can declare variables anywhere you like throughout the source code. So before, on the left, you see int ij is at the top of the module start, of the procedure start, and on the right you can declare it as soon as you need to use it, so it's actually within the for loop. Okay. On this page, this is what the ARM code that Charm generates looks like, and that's output by the compiler. And what I'm showing here is on the left, it's using the old floating point emulator instructions. So if you look at halfway down in red, you can see MUFI, which is multiply extended, floating point extended, that the emulator uses. And on the right, if you set the VFP flag, instead it will generate an FMLD, which is part of the EFP coprocessor instruction set, and is a lot faster. And the other thing you can see is the FM stat in red. That's, does anybody know any VFP coprocessor stuff? No? Okay, let's have a talk a little bit about dependencies, about the consequences of having import-export. Because we don't have any linkage files we write ourselves, there's a problem if you have two modules and they depend on each other, and that's called a cyclic dependency. And essentially you can't compile either module because you need to compile every module first. So there are ways around that, and I've just listed two here. So the first one is a compile time resolution of that problem. And the way to get around it is, if A depends on B and B depends on A, if you say split B into B and C, such that A depends only on C, and of course B will depend on C, then you've resolved that cyclic dependency. If that's not practical, a more interesting way, more fun way, you don't need to use very often, probably only for writing a big project, is to use something called dependency injection. I don't know if any of you have heard of that. But essentially, we've got A depends on B, and B wants to call A. So what B does is exposes a method that A can inject a runtime reference into, and then when B wants to call A, it uses that reference to call out to A. Does that make sense? Okay. It's probably a bit technical, but that's a couple of the things I've had to do as a result of using import-export. Right. So to finish off this set of slides, there you go, there's the epilogue. Why not give it a go? It's free, it's easy to use, and it's really easy to install. And actually it comes with the RISC OS distribution, albeit a rather older version than I've got on the website at the moment. Please pick up a card. I think we've probably got time to just show you Charm running on the Raspberry Pi. So I'll switch over and do that now. If you've got any questions while I'm doing that, please shout out. I'm just going to quit these, get them out of the way. Okay. So Charm just unzipped into a Charm folder, which can sit anywhere pretty much. That is the Charm shell, so when I double click it, it should install itself on the icon bar. And I've got it set so that you can see the login window. We can compile something in Charm. What I'm going to do is drag and drop the Charm compile operation on the tools to show you what happens. So here you can see it compiling and linking all the charm tools. It's not as quick on the Raspberry Pi as on the PC, actually. The ARM11 chip isn't that fast, but it's still pretty good. So that took about 20 seconds. I'll tell you at the end how long it took. That is the majority of the code that comes with charm that we've just compiled. If I right-click on the icon, you can see the options are available. So that tells you the release and when it was made. This is Hang Out Today. You can turn that login window off if you want. When an error happens, you have an option of using throwback. If you don't like using the charm editor, you can use any editor that supports throwback, like Zap, I think, and Stronghead. Probably there aren't that many options, but one that's worth mentioning is this target VFP. If you're going to run this on the Raspberry Pi, I suggest you set that and you rebuild the charm distribution, and it will rebuild itself to use VFP, and everything will be a lot faster if you want to use floating point. I can show you the Mandelbrot set demo quickly, which I'll be demonstrating outside. So that's called Mandel. I have some pre-built, some data of locations that are quite interesting in the set in this config directory. So all the demos are in this bin directory here. So for instance, that SID one that you saw the source code for, if I run it now, there you go, there's all the prime numbers up to 1,000. That's from the Mandelbrot demo. Just draws a little Mandelbrot set, and as you can see that was pretty quick, but it was quite a small window. Let's have a look at Flake 5. So I just do a drag and drop, and various things are configured, like the size of the window and stuff to do with the palette. The palette's still a bit dodgy on the version of RISC OS I've got, so I'll stick with this palette. And it draws it kind of in stages, so that you get an idea of what you're looking at without having to wait for the full resolution. As you can see, it's pretty quick. If I'm interested in looking at, say, that bit, and I can zoom in on it like this by doing a click drag operation, and with a bit of luck. Here we go. So one more thing I'll show you is that Decapedes demo that I mentioned earlier that the kids might like. Quit out of this. There is sound on this, but it's not hooked up. I can hear it. Can you hear that? You can control the green centipede, but I'm not going to try it. I mean, it is possible to get rid of the 3 red ones, but it takes a bit of skill and practice, I've got to admit. So if you want to do any sound or anything or graphics, this would be a good program to have a look at. I'll just quickly demo some of the other programs then. Graph was the one that used the maths library. A bit hard to see, but it's drawn various mathematical functions there. And Chinese checkers. Yeah. So if I do restore, you can stay where you are in the game and then just make a move. I'm green, and I can jump over, so I'll jump over there. And then it's thinking about what it's going to do. It's done that. It might not look like a particularly good move, but in my experience, it makes a pretty good move and move after, sort of thing. Okay, I think I'm going to leave it there. I'll just answer any questions that you might have, and we'll call it a day.
What version of Raspberry Pi RISC OS?
This is the 22nd of September release, I believe, and on that there is a release of Charm. It's release 2.5.8, I believe, but as I say, it's so out of date, hasn't got the BFP instruction set improvements on it, so I would definitely, if you're going to use Charm, I would download it and stick it on. Yeah?
Compatibility with where you were last year? Is it backward compatible?
No, language has changed. The syntax of the language has changed. But if you it's been added to, and also, well, like if you change all the end underscores to curly braces, and people that still put end underscores in their programs are going to have to do the same. But it's not a big deal. I'm constantly updating the whole of the code base as I change the language and it evolves. So it only takes. The editor is actually quite powerful. It's got macro facilities, and I'll just show you the editor very quickly. Hang on. So you can actually do global replaces effectively on the whole of this code base in one go. And if you want to have a look at some Charm source code, this is the bit that does the Mandelbrot set. That's what it looks like. And if I go down to the bit that actually does the set generation, you can have a look at that code. Which was what you saw the assembler code for earlier, by the way. It's this get escape iteration. So in the middle of the screen there. What was the question again? Sorry.
Well, how much change are going to need to make the source code?
Oh, how much?
To keep up to date.
Not much now. I'm not going to change it much more now. So, honest go. But if I do, it won't be a problem.
Is there a written manual?
You could always print out what's on the website. Why would you like one?
Well, it would be useful to
Well,
look at that language.
It would be useful, however, since this is all free and that would cost money, I'm not sure I'm going to do it. I could provide a PDF if people think it would be useful, but the website is pretty good. At least I think it's pretty good. I don't know if people have a look at it. It's got everything you might need on it. It's quite extensive.
Can you call it probably like wget to do something?
wget is a Linux program.
There is a RISC OS support too.
Yeah, but there's a RISC OS support to the Raspberry Pi, but it doesn't run Linux commands.
Yeah, you can call with RISC OS programs wget to do things. The system call you just send the same Charm.
Yes.
There's
There's a function in the RISC OS operating system that lets you run a task, and in fact that's the way the compiler and the linker are run. They're run. You can run them from the command line as well, but the shell runs them using that call, passing in the correct parameters. Anybody else? All right, thanks very much for coming.